Hi everybody, it's Mrs. Cassell. So full disclosure, this is take 2 because my microphone died. So sorry, this one will be briefer and a little less authentic than my first recording here. But I get asked questions by you guys, and I am a Python novice, just like you are. So everything I know about it, I've learned from doing the CoderZ simulation. So I thought, gosh, I should be recording this so you can see me work through things. So alas, you're going to miss the full exploratory experience here because I know what the answer is because I'd finished my recording, was at the end, and then my microphone died. And honestly, it's easier to re-record it than it is to go in and fuss with my video editor and, splice a bunch of videos together. It's very late at night when I do anything, you guys. Okay, here we go. We're on my first PController. Our drive distance algorithm is still not perfect yet. We're counting on Ruby's braking distance, which depends on her velocity and the angle of the plane. So in this mission, we'd like to use a better algorithm, the PController. PController is a closed-loop controller. So we already learned about the two-state controller in the cruise control missions. I do not remember that. I'll have to go back and look at that. This was also an example of a closed-loop controller. On every loop iteration, the controller will adjust Ruby's speed to be proportional to the distance remaining, hence PController. Okay, so P is for proportional. So what I hear this saying is that we've got a while loop going, and it's going to be essentially checking the remaining distance. So it's going to check where I am compared to where I'm supposed to be, and then as it compares those two numbers, it's going to change my speed based on that number. How much will it change my speed? Proportional to the number that I set in my PController. So let's do this thing. Okay, so they've got an example here. If I'm driving with a P equals 10, okay, so 5 meters, if that's the distance remaining, it's saying that it turns my driving speed into 50 centimeters per second. First, the math of this annoys me a little bit as a physics teacher, but I can get over it and understand that units and variables are a little different. So I do see that the speed is decreasing the closer we get. All right, they glossed over the reality that with this phenomenon, then it gets really impossible to reach your destination. So this is the line we set. So I'm in line 23. In this line, we set the desired speed to be proportional to the distance left. The minimum and maximum functions are there to find the speed to stay within a range. Okay, that makes sense. So I'm saying that here I'm going to say that my speed is going to be proportional to the distance left, and I don't want that number to be, I want it to be somewhere between negative 100 speed and 100 speed. Okay, so I'm going to play around with the value for P, and we're going to see what happens. So, I don't know. They set it up with 50, so I'd like to try 50. Super hilarious. I didn't hear any of the sounds before when I was doing stuff. Okay, so I stopped right about there. So I'm going to reset this, and I know that it's got my print screen on here. I figured out my mistake when I did this the first time. So I am going to uncomment out the print right here. And it says printing the desired speed, so it's asking me to figure out the desired speed. I might have it print something else once we get there. So anyway, okay, so it said try 200. So we're going to go ahead and run that simulation. So that's pretty annoying because you'll notice that I am not on the square, and I did a bunch of bouncing back and forth centered around that spot. So I'm really curious. I wish I could mark that spot easily. Let's go ahead and make this insane. Let's Mythbusters this thing. Let's make it 300 and just see what happens. Okay, so looks like it was going to work there for a second, but instead we're still popping back and forth. Very volatile with that massive proportion. And my perception is that I'm ending about the same place as the other ones. So, um, I want to sort of verify that that's true. So what I'm going to do is instead of having the print screen be the desired speed, I want to know, I want to know where I am, honestly. So I'm going to have it print the distance traveled. Let's see how that works. This does what I wanted to. And 300 was too nutso pants. So we're going to put it back on 50 where it started. All right. So I'm going 0. Okay. So I'm ending about a little less than 4 meters from where I started. So just to verify, because I was thinking that it looked like I was about the same distance away, I'm going to pop this up to 200 like it suggested. And then I'm going to see if I end up about 4 meters away. Ooh, I went way past 4, but then I did this nice little bounce back and forth. And where am I ending up? I'm stopping at 4 meters. Okay, so let me go look through my code here because I've had 2 examples with very different proportions that landed me in the same place. It turns out that's not the place I want to be. So my error in this code isn't with my PController, it's about how I'm calculating my distance. So, all right. So I'm just going to read through the whole thing. All right, I'm importing all of my methods and functions up here and the other stuff. You can tell I'm still a learner, like I said. All right, I'm initializing a robot. So now I have a robot and I have time and I can do math. So, right here. So here's our first thing. It says our destination is 4 meters away from where we started. And that's what I was seeing, that's where I was ending up. So that makes sense. So this code is working to deliver me to location 4 meters from the origin, but that's not where my target is. Okay, so that's the number I'm going to fix here in a second. Looks like I'm doing my GPS, so I'm checking what's my initial position. Here, I can reset this also so that it matches what we're doing. So first thing that's happening is I'm checking my GPS. Where am I? 0, 0, 0. Then I'm starting my while loop. So I'm checking my position again at each iteration in time. And then I'm calculating how far I've gone between where I started and where I am now. So this is how I'm figuring out my distance travel. So I started at 0 and I'm using the Pythagorean theorem to determine where am I at because they're taking my x, my y, and my z, and they're finding out, okay, if this is a triangle x, and then z, what's the length of my hypotenuse. So that's where this bit of math is coming from up here. So the error is the difference between the desired destination and the actual destination. So the distance that's left, and I'll admit, first time I read this, I immediately thought left versus right, which isn't what it means. It means distance remaining. So if I were coding this, I'd use a different variable right there, right? I'd label that differently because I would, that's confusing for me. In fact, let's do that just to, make sure that makes sense. So I want to do distance remaining. Okay, and I want to make sure I change that all the other places. So, um, I'm expecting that number to eventually be 0, right? That's when I'm on my target, is when that number is 0. So my destination is 4 right now, and once I've traveled 4, this number becomes 0. So my PController right here says that my speed should be between -100 and +100, and my speed should be 200 times whatever my distance remaining is. Yeah. Okay, that makes more sense for me reading this. So, and then it says, hey, that's my desired speed. Please set the motors accordingly. So I chose to print the distance traveled. If the speed is low enough, then we reach the desired distance. So this is really helpful, right? This is so those of you with math backgrounds can figure out that, gosh, we're approaching an asymptote of 0, but that means we never reach it. So in physical reality, we do often, because things are bigger than single atoms. So so they had to add a thing to break the while loop here to so that you could boot out and actually apply the brakes and stop the robot for real. Okay, so now, here, there's a measuring device on here, I think, right? Isn't there some tools I can use? Tools, gyroscope. I thought there were tools, you guys. Ooh, Ruby, what a pretty place you live. Okay. So, I'll go look that up in a second, okay? Because I thought there was a measuring tool that you could use, or can you just like click on here? Speed, gyroscope, side tilt, speed. No, I don't want any of that stuff. Okay, so it'd be super useful if they had a measuring tool on here, but okay, I can live with that. All right, so desired distance is clearly not 4. So we're going to go ahead and try 5. And I'm going to leave it on, I don't like that bouncy bounce, so I'm going to put it on 50. This was like a trick question. If any worked on this one. Yeah, look how much better that is. And sure enough, my final distance, my final position there, my distance traveled is like 5. So I'm going to go ahead and plunk this up to 6 and see if that do what I want it to do. Yeah, that feels good. Okay, so I'm going to click try again so you can see my code right there. Okay, so the trick in this one was actually discovering that you were only going distance that was insufficient. So the two things that helped me figure that out were first changing what was printing so that instead of showing me my speed, like duh, I get that it's slowing down, that's helpful. Um, Instead, I changed what was printing so that I could see where am I in the universe, especially because I couldn't measure. So once I did that, that gave me some clues because as I changed my p-value, I could see that, yep, I really was ending up in the same location, but that location was not where my target actually was. So um, then being able to read through my code and sort of look at it line by line so I understood what it was doing helped me figure out that up here it says where my destination is. And my destination is used down here to calculate that distance remaining, that distance left that I renamed, which is what um, I needed to calculate when I should stop, right, and what my speed should be. So I had to change that destination to actually match the physical reality. Phew, that was hard, you guys.